we can use the original directions, the north, south, east, and west, to determine the position of an object with respect to a given observing point using the original directions. Suppose that the observing point is the origin point, then draw a ray to determine the position of the object with respect to the observing point. For example, an object at 40 degrees north of west, you start at the west, the angle goes from west to north. So initial side of the angle is the direction of the west, then you go 40 degrees above the west to represent 40 degrees north of west. If an object is at 30 degrees north of east, you are at the east, so you go from east to north 30 degrees. If an object is 30 degrees east of north, so you go from the north to the east 30 degrees. And if an object is at the eastern north, so we are not given any angle measure, so the object is in the middle between the north and east, so it's 45 degrees from either east or north. Number 4, a ship moves with velocity 12 km per hour in the direction 40 degrees south of west. So we have the 4 original directions and the origin point. Start by the origin point. The first ship go 40 degrees south of the west. 40 degrees south of the west means that you start by the west and go down 40 degrees to the direction of the south. So OA represents the motion of the first ship. At the same time, another ship moves with velocity 20 km per hour in the direction of the north of west. The north of the west means we're not given an angle. The ray is in the middle between the north and the west at 45 degrees from the west. So the ray OB represents the motion of the second ship. Find the distance between the two ships after 3 hours from the beginning of their motion. The first ship moves with a velocity of 12 km per hour. So in 3 hours, the distance equals velocity times time. So the distance covered by the first ship, OA, equals the velocity of the ship is 12 km per hour. So 12 times 3 hours, so times 3 to be 36 kilometers. This is the distance covered by the first ship. The distance covered by the second ship, or OB, equals the speed of the second ship is 20 kilometers per hour in 3 hours. So the distance is 20 times the speed times time, or 20 times 3 hours to be 60 kilometers. In triangle OBA, so the first ship covers the distance OA, or 36 kilometers. The second ship covers OB, or 60 kilometers. We want the distance between the two ships, so we want to find AB. Add the two angles to find the measure of angle AOB, so 40 and 45 to be 85 degrees. In triangle AOB, we have two sides and the included angle. We want to find the length of the third side, AB. Use the cosine law. AB squared equals the sum of the squares of the other two sides, 60 squared plus 36 squared minus 2 times the product of the lengths of the two sides, or multiply the lengths of the two sides, so 60 times 36 times cosine of the included angle O times cosine 85 degrees. So finally, don't forget to take the square root of the final answer. AB equals 67 kilometers, and this represents the distance between the two ships A and B.